Good evening, class. Today we will study electrical instruments. It's not based on numericals, it's totally theoretical chapter. So, what we know about electrical instrument? Generally, we come across current, voltage, power, energy, flux, and all these things. Okay, we cannot see it through our eyes. Okay, the instrument is that who used to measure these things, measure these quantities, known as electrical measuring instruments or electrical instrument. Okay, for example, we measure current, voltage, power through ammeter, voltmeter, wattmeter, energy meter, all these things. If you all have studied in 9th and also, we have seen this multimeters there. Okay, multimeter we can calculate all these things: ammeter, voltmeter, wattmeter, all this. Okay, but for engineering level, we have to classify the measuring instrument. How we'll do that? See, it is classified in two parts. First is absolute instruments, and second one is secondary instruments. Okay, so what is an absolute instrument? Absolute instrument is such instrument do not have require any comparison with any other standard instrument. Okay, we may take example of tangent galvanometer, which gives the value of current to be measured in terms of tangent of the angle of deflection, okay, which is produced, okay, angle of deflection. The horizontal component of the Earth's magnetic field, the radius and the number of turns of wires used. Okay, and what is in secondary instrument? We may write also. Tangent galvanometer, what is secondary instruments? The deflection of such instrument gives the magnitude of electrical quantity to be measured directly. They measure directly the electrical quantities. Okay, these instruments are required to be calibrated by comparison with either an absolute instrument or with secondary instrument, which is already being calibrated before putting into use. Okay, we also use in practicals secondary instrument. Okay, absolute instruments are mostly used in standard laboratories, and similar institution and secondary instruments are widely used in practice. So we will concentrate only on secondary instruments in this chapter. Okay, so write the topic. This chapter is totally theoretical, so even I am feeling little bit of difficult. Okay, Electrical measuring instrument may also be classified according to the kind of quantity being measured, kind of current for which they are designed. Okay, so what are the secondary instrument? Indicating instrument, recording instruments, integrating instruments. These are types of secondary instrument. So just write it over here. What you'll write? Types indicating instruments. Now what are these indicating instruments? I've already told you about ammeter, voltmeter, wattmeter. These are only indicating instruments. So just write examples so that you people can understand. Voltmeter, multimeter is also there. Why they are not fitting? And so on. Now second, we will go for recording instruments. So what is recording instrument? They keep continuous record of variations of the magnitude of an electrical quantity. Okay, they are recording it time to time, different period of time. Okay, in such instrument, the moving system carries an ink pen which touch lightly a sheet of paper wrapping over a drum. Means just like we have seen that type. Means if a patient go for an ECG, you have seen the graph like this. Okay, these all things are coming in recording instrument. Okay, making curves. If you have seen that making graph in microprocessor, if you all have done work in microprocessor, you would have printed few graphs or scanned few graphs in that from microprocessor. Okay, that is also coming recording instrument. Electric bill, how they calculate it? Only through recording instrument. Okay, now the third one is integrating instrument. What is it? What is it? Integrating instrument, which measure the total amount of either quantity of electricity or electrical energy supplied over a period of time. The summation given by such an instrument is the product of time and an electrical quantity under measurement, the ampere per hour. Okay, means the values. We may say the values. Okay, now what we will do? We will go for principle of operation of electrical measuring instrument. What is it? What is it? we'll classify these things. Make a paragraph. Write the effects. Utilizing the effect. And suitability for type of measurement. Okay. Magnetic magnetic effect. First we'll go for magnetic effect. I'm able to see now. Sorry for this problem. Actually, right now my outside out of station, that's why I'm facing these problems. Okay. Magnetic field is utilized by ammeter, voltmeter, wattmeter, okay, and other electrical instrument, as I have told you earlier. And suitability for for type of measurements. Current, voltage, you can see from this, current, voltage, power, energy, and so on. Okay, next is thermal effect. How instrument utilizing the effects? What are the instrument? Ammeter and voltmeter. And voltmeter. Current and voltage for both AC and DC system is suitable for the type of measurement. Okay. Suitability for type of measurement, that is current and voltage. For both AC and DC system. Chemical effect. Integrating metals. Just continue, right? Electrostatic effect. instrument utilizing the effect is only voltmeters. Okay, you have to learn this one. Only voltmeter. Okay, only voltage. You have only for both AC and DC system. Okay. Wait. Electromagnetic induction effect. Voltmeter, ammeter, wattmeter, and energy meter. For measuring of, if we have written voltmeter, ammeter, energy meter itself, showing that voltage, current, power, and energy in AC system only. So write it down and memorize it properly. I'm again telling the same thing. This is totally theoretical chapter, so you have to memorize only. Nothing else we can do with this chapter. Okay, next is essentials of indicating instruments. What is this indicating instrument? That consists essentially of a pointer moving. We have seen, no, this type of drawing is not good. Okay, that pointer moves from this to this side, like galvanometer. You have even seen in that speedometer. Okay, so for satisfactory working of indicating instruments, the torques required. Okay, the so required torques are deflecting torque first, controlling torque, okay, we'll go topic by topics. Okay, what is deflecting torque? Deflecting torque is produced by making use of one of the magnetic, heating, chemical, electrostatic, and electromagnetic induction effect of current, voltage, and causes the moving system of instrument to move from its zero position. I told you, no, from 0 to it varies. Okay, the method of producing this torque depends upon the type of the instrument and will be discussed individually in another section. Okay, so deflecting torque means the pointer must be going to deflect from one point to another. if this is pointer, negative way in positive way. Okay, write in comment. Though it is a rough diagram, example of deflecting torque I have already discussed, but you people also write in comment example of deflecting torque. Okay, now we'll study controlling torque. What is controlling torque? Word itself telling you to control means the torque which is used for controlling type of machines or anything like that. Okay, how it work, what are those controlling torque, we'll study now. The magnitude of sorry, this torque opposes the deflection torque and increases with the increase in deflection of the moving system. Deflection is always the same for a given value of quantity to be measured. Under the influence of controlling torque, the pointer, okay, or moving system will return to its zero position on removing the source producing the deflection torque. Without the controlling system, the pointer would swing over its maximum. Moreover, once deflection, it would not return to its zero position or removing the source producing the deflection torque. A spring, the controlling torque is the indicating instrument is created either by a spring or by a gravity. Okay, by a spring or by a gravity. So it is already given only spring control and gravity control. Okay, in spring control something like that. Okay, I'm making a rough diagram. Okay, this is pointer. Now both of them are spring. You may name it spring 1, spring 2, spring A, spring B. Okay, this is scale. It is known as graduated scale. This is pointer, as we all know. Gelled bearing. Okay, This is how springs controlling torque. Okay. Now we will go for gravity control. Gravity control temperature coefficient to stiffness of the spring result in a temperature coefficient in indication of the instrument. Suppose spring result in displacement in the zero position of the moving system. Okay. Again I am drawing for gravity control. This is 0.